Good evening, this is Jack Long. I am the Mad Scientist, and we're going to be talking about dust collection layout and design. And this is going to be on a simple system. It's part 2 out of 5, and we're going to start talking about the size of the pipe at the machine, working our way from the machines back into the dust collector itself. Okay, so with that being said, let's get into it. What we're going to move into is laying out the correct sizing of pipe and how to figure it into a shop. So when people go out and buy dust collectors, they always want to go out and buy a dust collector first and then attach the machines. And when you're designing a system, you actually start at the machines and move to the dust collector, not the other way around. Your dust collector is sized based on your load, not the other way around. And with that in mind, typically you're going to oversize your dust collector so you always have room to grow. So, and that's in a perfect world. And we all know that the world is not perfect. So occasionally you're going to get into a scenario where you already own a dust collector and you have to figure out different ways to make that dust collector work, which is where you start putting in blast gates and alternate trunk lines and things of that nature. So what we need to discuss in this is something that I'm sure you know of, which is your CFM, which is your cubic feet per minute versus the area squared of your pipe. Okay, and we will go through a formulation here on the next page about exactly how to figure out this value right here. Okay, so what numbers I use to figure out my CFM that goes back to build into my dust collector is 51.75 CFM per 1 square inch of pipe. Okay, so we're going to take this formula and we're going to use it on the following page. And when we're using that, that's when we're going to start talking about our pipe layout options. Sometimes it's you add 2 or 3 different pipes together to enlarge it, and we'll cover this in more detail in a moment, just to make everything lay out easier. And then at the end of it, what we're going to talk about is inflow versus exhaust. And on the inflow, it's basically how much air is going into it, and that's what we're going to be covering using these formulas. Now, I told you before that we wanted to have 51.75 CFM per inch squared. Oop, that's supposed to be an M. Okay, so the question is where all these numbers come from and why that starts to play into it. And when I'm looking at my pipe, I'm going to start up my machine, and let's say that I've got a planer, for instance, and the planer has got a 5-inch port. Okay, so that 5-inch port has got a square area, and the way you find your square area of it is pi times radius squared, or 3.14 times your radius squared. And I did a quick little spreadsheet here just for the interest of time. So a 5-inch diameter port has a radius of 2.5 and a square area of 19.63 inches. And where that comes into play is that in order for you to pull 51.75 CFM on a 19.63 square inches, it gives you 1,116 requirement for your dust collector. Okay, so you need at least around about 1,000 CFM to draw adequately a 5-inch port and to be able to pull away your chips in a vertical motion to clear the machine. Okay, so where these numbers start to come into play is when you start adding the systems together. Okay, so let's go over here and let's draw us up. Let me clear this page out here. and let's start a fictitious shop. All right, so let's say that I have over in my shop, I have a shaper. This is a shaper. I have another one that's a joiner. I know these don't look like our machines. No charge for the artwork. Down here I have a sander, like a wide belt, something like that. Okay, and on our sander we have a 8-inch port. On our joiner we have a 4-inch port, and our shaper we have a 3-inch port. If I go back to my previous chart, on my shaper I have a 7.07 square area, so I got 7.07 here. My 4-inch is 12.56, so I got 12.56, and my 8-inch sander is a 50.26. Okay, so where these numbers start to come together is that when you are running through your pipes and your pipes are coming together, as the pipes, the square area is added from machine to machine to machine, and you're coming into branches and you're going back out into the next trunk line, you have to take this square area of your given port and add those together to find the next CFM. Okay, so this is the purpose for me making this chart like this, is so that we can kind of at a glance be able to figure out what the next pipe should be. So if I was coming into this and I had two 4-inch pipes, and you say, okay, 4-inch, that makes 8-inch, but it doesn't. So a 4-inch is 12, and then the second 4-inch is going to wind up making it about a 25. So it's going to land somewhere between a 5 and a 6. So 25 square inches of those added dimensions lands somewhere in here. Okay. So if I had to have a choice, what I would do is I would jump up to this size. Oop, I don't want to do that because I'll lose that number here. Let me make a drawing pin instead of an eraser. I would jump up to this size. And the rule of thumb that I was taught is plus or minus 10%. So you could either go up or you could go down 10% and still not affect your CFM that's going to go through your pipe. Okay? So what we need to do is we need to go back over to our shop, and now we've got a 7, and we're going to go up here. So now this is going to wind up being what, 19.63. So a 19.63 is my new square area. I go back to my chart. I look for, oh, look, here's one that just happens to wind up being perfect. This one is now a 5-inch pipe. So when these two add together, one of my branches is going to come in like this. I'm coming in with my air. I have another port that comes in. This is my 3, this is my 4. It blends and it comes out as a 5. Okay, does that make sense? I hope so. If not, let me know and I'll see if I can't re-explain it, but I think that this is simple enough. Now what I go into this is I take this now 5-inch, and I go from a 19.63 and I add that on to my 50.26, and it winds up being 9896, so 69.89. And I go back and I look at my next size, and it's really close to this. 69.89. This one's 63 or 78. I can either go up or down. On this one, I'm going to choose this, and we're going to go into this size right here. And the reason I'm going to choose that one is because when I make my pipe smaller, it speeds the airflow up. But I also still want to stay within my 10% rule. So you're over under of 10%. If I go too big, then the square area becomes bigger, and the air velocity at the same CFM going through it slows down. And when you slow your velocity down, then you will have your particulates fall out. Okay? So the reason that I was going to take this one and go smaller is because my CFM, my velocity of the air, not the CFM, is going to speed up. And what that's going to do is that's going to take all these particulates that's being brought over to us. This is dust, so it's not so bad, but these are typically going to be larger particles. So they're going to be shavings and things like that, stuff to have mass to them. So as they're traveling across this line, I've now got a 5-inch and a 9-inch. Oop, what am I drawing here? I've got a 9-inch. Man, I am just making all kinds of mistakes here. An 8-inch, a 5-inch, and it comes out a 9-inch. Okay? So this is what's going to feed on to whatever the next thing is. And maybe I've got 4 or 5 or 6 more machines that I'm going to pick up along the way. Or this is going to go from here and go straight into the dust collector. And if this is my dust collector here, I now know that my 9-inch pipe, if I go back, I'm going to need a dust collector that's approximately 3,300 CFM. And it could be just a little bit more, but you don't want to go less, because if you go less, then the velocity that's going through that 9-inch pipe is going to slow down. And when you slow your velocity down, your particulates will fall out. Okay, so now let's that is about as basic of a system as we can have. We just got 3 things that come through it. So as always, guys, be safe out there. We don't do anything that's worth going to the hospital for, so make sure that if you're up in the air that you got your fall protection and that you're taking care of yourself, because we all got somebody we want to go home to. And as always, let's go make a million. Have a great night.